Okay, so good day, everyone. The topic for this video is biconditional. So biconditional is where we combine propositions that expresses that two propositions have the same truth na value. Okay, so suppose we have two statements P and Q. If P implies Q and Q implies P, so as you notice, P implies Q is a conditional statement. The Q implies P is the converse of this original conditional P implies Q. Okay, so if P implies Q and Q also implies P, then we can say that P is equivalent to Q. Okay, it is also called as the biconditional of P and Q and is denoted by the symbolic notation. It is often stated as P if and only if Q. So you take note this of this clause if and only if. So this is the truth table for the biconditional. So the biconditional will only be true if both the P and Q have the same truth na values. Okay, so if P and Q are both true, then the biconditional will also be true. And if both the P and Q have a false na value, then the biconditional is also true. So what's the pattern? If we say biconditional, the biconditional will only have a true value if P and Q have the same truth na values. Okay, but it will be false if P and Q will have the opposite na values. Okay, so as you can see, true false results to false and false true results to false. So let's have an example. Let P and Q be these statements. P states that I will submit all the problem sets, and Q states that I will pass ComSci 56. P implies Q states that if you submit all the problem sets, then you will pass ComSci 56. Okay, while Q implies P states that if I pass ComSci 56, then it's most likely that I have submitted all the problem sets. Okay, the biconditional states that I will pass ComSci 56 if and only if I submit all the problem sets. So this will be true if the P and Q are both true, meaning you pass the ComSci 56, it only means that you submitted all the problem sets. And it will also be true if P and Q are both false. Okay, so if you did not submit your problem sets, then it's most likely that you did not pass your ComSci 56. Okay, or you will not pass your ComSci 56. But when would the biconditional be false? If your P and Q have opposite na truth values. For instance, you passed your ComSci 56, but you did not submit all the problem sets. So there's something fishy with the way your teacher has assessed you, right? So, and also, it will be false if you submitted all the problem sets, but you did not pass the ComSci 56. So that's the time that you have to question your teacher why you did not pass, right? When in fact you have submitted all the problem sets. So that means that it will result to false also. Okay.